So first of all, when we talk about geometry, you can figure it out that it is made of two words, geo and metry. Metry means measurement, geo means earth. So it's basically the science we use uh, to measure the land, like the basically when we talk in the term of area, perimeter, volumes. So those concepts, all the geographical features around us when we try to measure them. So we use the logic of geometry in that. Euclid geometry, why we talk about Euclid geometry? Because Euclid did remarkable work to understand the concept of geometry. There was a time, you remember, during Renaissance. So during the time of Renaissance or the Industrial Revolution, when Pope were dominating the world, during that time, probably there were a lot of hypotheses, there were a lot of theorems which was being postulated by popes, saying that Earth is the center of gravity, Earth is flat. You heard of stories of Galileo and other famous scientists who were being punished because when they said that the sun is the center of the universe and all planets, including Earth, revolves around that. So during that time, there's a remarkable work was done by Euclid to understand the concept of geometry and which we use till now to work on the classical geometric theory. So before we get into the Euclid axioms and all to understand what Euclid has actually mentioned in there, uh, probably we need to understand few words here. So few words, mathematical words here. So one word we need to understand is the statement. So one word we need to understand is the statement. The next word what we need to understand here is the axiom. So, so correct me if I do not pronounce it properly. Then it is postulate. Postulates. Then the fourth word which we need to understand here is the theorem. So what is the difference between them? So probably we use all of them to like what you say as a synonyms of one another. But basically here we can try to understand the difference between each terms. So we try to understand the difference between what is statement, what is axiom, what is postulate, what is theorem, what is corollary. Okay, so I'll start with the first term. The first term is the statement. So I'll start with statement. So if I talk about statement, so what is basically statement? So statement, when we say statement, what is basically statement? The statement is basically a sentence which can be judged to be true or false. So statement is basically the sentence. It is basically the sentence which can be judged, which can be judged, which can be judged to be true or false, to be true or false. So it can be judged, and based upon judgment, I can figure it out that is the sentence is a true or false. So some sentence which you cannot judge that it is either true or false, then it can't be said a statement. Like for example, if I give you an example, if I say that suppose x plus 10 is equal to 15. So if I say x plus 10 is if x plus 10 is greater than 15, if I'm using a sentence called x plus 10 is greater than 15, so it is basically a sentence. It is basically a sentence, but it is not a statement. But it is not a statement. Why it is not a statement? Because I cannot judge this. This is true or false. Okay, I cannot judge this. While if I take x less than 5, if I take a x less than 5, if I take a x less than 5, then x plus 10 greater than 15 will turn to be false. It turn to be false. While if I take x greater than 6, then x plus 10 greater than 15 will turn to be true. I hope you are understanding. So if you take any integer value of less than 5, then x plus 10 greater than 15 to be to false. While if I take any x value greater than 6, then x plus 10 greater than 15 will turn to true. So here you cannot judge this is true or false. So it certain condition it is true, on certain condition this is false. So this is not a statement. Statement is something which can be judged. So you can make it out it's true or false. If I say that sum of all angles in a triangle is 270 degrees, so it's a false statement. So we can judge it mathematically. So we took the help of certain axioms and all, we prove it and we said no, this false. If I say sum of all angles in a quadrilateral is 360 degree, so we can prove it and figure it out. Yeah, it's true statement. So statement is something which we can judge and we can come up with a conclusion that it's true, or is it true or is it false. So if you can do that judgment, then it is the statement. Otherwise it is a sentence. We have heard this word statement very commonly when we have seen some criminal kind of investigation, criminal reporting kind of investigation, like crime patrol or crime alert, something something, or whenever any incident happen, you see police go and try to get the statement from different people. So police call people, different people who are,
Yes, sir.
and people ask them to give you a statement. People never, police never say that you have to give you a sentence. So you have to give your statement, and so different people come and they do the narration of the incident according to their viewpoint. Then police sit together different and they come together. They try to narrate visually what would have happened, and by using the statement from different person, and thereby they can get to know who all are talking truth or who all are talking false, wherever the contradiction is happening, all that. So there the investigation was done based on the statement. So statement are basically those sentences which can be judged to be true or false. So that way I believe you can understand what is statement. So once we understood what is statement, then the next term what we need to understand here is basically axioms. So next thing we need to understand here is basically axioms. So when we say axioms, so they are basically, when we say axioms, they are basically self-evident. They are basically self-evident true statement. They're basically self-evident true statement. They're basically self-evident true statement which is used throughout the mathematics, which is used throughout the mathematics. Okay, which is used throughout the mathematics. So they are basically self-evident true statement which are being used throughout mathematics, and 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 they are not spatially linked to any particular concept of mathematics, and they're not specifically linked to geometry and all, because normally axioms and all, we see this term normally in geometry more. So they are not specifically linked to geometry. So they are basically called as axioms. So now the question arises, there's huge confusion is there with regard to the two term. One is axiom, another one is called postulate. So postulate are basically self-evident true statement which we use only for geometry. So which we use only for geometry. So the sum of all angles in a triangle is 180 degree. Exterior angle is equal to sum of two interior opposite angle. So some like sum of all the angle possibly around a circle is 360 degrees. So if you have self-evident true statement which we use only for geometry, then it is called a postulate. Axiom is something. So axiom is something. Axiom is something. Those what you say, self-evident true statement which we use in all other branches anywhere, either in arithmetic or algebra or anything, any analytical geometry, anywhere we use, doesn't matter, it can be geometry, it can be anywhere, any domain, half plus half is equal to 1. So this is axiom. Okay, what you say, half of any angle, half of any angle is always less than the angle, or the bisectors of any angle is less than the angle, anything. So when we say something like this, so it can be applied in any domain. So self-evident true statement, which we use throughout mathematics to prove or disprove any theorems or any corollary. So that we called it axiom. They are not specifically linked to any discipline, like geometry or any discipline. So when we say postulate, basically postulates are those axioms which we only use in geometry. So when we say postulates, so postulates are such axiom. Postulate are, are those self-evident postulates are basically those self-evident true statement. Postulates are basically self-evident true statement which is used only for geometry, which is used for geometry only. So when we work on geometry, so the such kind of self-evident true statement which we use, then it is called as postulate. So normally axiom postulates are something which is very common and which we use in day-to-day life as a synonyms. Like in physics, weight and mass. Mass is different, weight is different. Mass is the quantity of matter contained in an object. Mass SI unit is kg, while weight is the force by which Earth attracts any object. So weight SI unit is newtons. But we in day to day life or generally solving any problems, we use the weight of a body is 50 kg. This is wrong statement. I hope you know that very well. This is a wrong thing, but we use as synonyms, although they are two different things. So like the same way axioms and postulates are used synonyms of each other, although postulates are basically self-evident statements, true statements which we only use for geometry, while axioms are self-evident true statements which can be used throughout in mathematics in any discipline. That is called as axiom. Like axiom, sun rises in the east. So if there's axiom called sun rises in the east or half plus half is one. So you never think to prove it, and 2 to the power 1 is 2. So you don't spend your time proving that 2
Yes, sir.
is 2 or 2 to the power 0 equal to 1. A to the power 0 is 1. We never try to spend any time because
Yes, sir.
they're already being, we already know that is there. So we don't spend time trying to prove or disprove them. Then the next thing we need to understand here is the theorem. The next thing what we try to understand here is the theorem. So when we say theorem, what are basically theorem? So theorems are basically statement. Theorem are basically their statement. Okay, with that requires, theorems are basically the statement that requires, theorems are basically the statement that requires a proof. Okay, that requires a proof. So such statements which you need to prove it. So you, that may or may not be true. So such kind of statements are called theorem. So like in statistics, probably when we go, we'll study something called test of hypothesis. We'll do uh, probably in 11th standard in statistics, we'll study test of hypothesis. So under test of hypothesis, we have Z test, T test, ANOVA, chi-square. Just simply, I know you'll not heard of this name. Simply, you, it will somewhere in future it will come for you. So Z test, T test, ANOVA, chi-square, lot of tests are there. So we basically do this test to prove or disprove any statement. So any statement for example, suppose Dhwani teacher, Amit sir has passed the statement that Dhwani in next exam will get 25 out of 25. So this is a statement which Amit sir has said. Now to prove or disprove this statement, you will use some axioms, because without axiom you cannot prove any theorem. No, axiom are self-evident true statement. So whenever we work on any theorem, we work on any theorem, we are trying to prove any theorem. So while proving the theorem, will take the support, and that support what will take the support of axioms. Like suppose, for example, there's a statement that, suppose there's a theorem. Suppose there's a theorem called sum of all angles. Suppose sum of all angles in a triangle. Suppose sum of all angles in a triangle is 180 degrees. Suppose this is a theorem, sum of all angles in a triangle is 180 degree. Now to prove this, sum of all angles in a triangle is 180 degree. What we'll do, we'll assume, suppose this is a triangle, and then we'll do some construction. We'll draw a parallel line, we'll draw a parallel line, DE. We'll do write some construction, draw a parallel line DE parallel to BC. Then we'll say, okay, whatever is this angle, it will be equal to this angle. So whatever is this angle, this will be equal to this angle. How this become equal? How DAB is equal to ABC? Then I'll write DAB is equal to ABC. Remember, whenever we have to do any theorem, You
Yes,
remember
sir.
some, we write some facts, some true statement which we know from knowledge of mathematics. So why this? We'll write in bracket alternate interior. I'll write alternate interior opposite angle because they alternate interior opposite angle. So what is this alternate interior opposite angle? It is a basically axiom. So we learned in parallel line, if the two parallel lines are intersected by a transversal line, then the concepts of corresponding angle, alternate interior opposite angle, then the sum of angles in the adjacent sides are supplementary. So we read those statements. So those statements are basically axioms. So whenever we have to prove or disprove any theorem, like we will do this chapter geometry. In geometry, we'll study triangles. After this, we'll study the chapter. After the Euclid geometry, we'll do congruent triangle. So congruency, similarity, so we'll take two triangles, prove that they're similar or they're congruent or not. So there we use axioms. So axioms are basically is being used to support any theorem. Okay, and once you have a theorem, once we understood the theorem, so once we understood the theorem, once we understood the theorem, so once we understood the theorem, so once we understood the theorem, so probably we get the we once we get the theorem, so probably then the fact what we can get from the theorem once we have understood the theorem, you understood what is axiom, what is postulate, what is statement, what is theorem. Now probably the fact, the outcome, what you get from the theorem, that we call as corollary. So basically when we say corollary, so corollary is basically, it is a statement. It is a statement. It is basically the statement whose truth, it is basically a statement whose truth, whose truth whose truth can be easily deducted, whose truth can be easily deducted, whose truth can be easily deducted from theorem. So from theorem. So from theorem. That is called corollary. You remember when we were gonna do problems on geometry, especially related to theorems, similarity and congruency. So we'll say by ASA theorem, and I
Yes,
say that
yes,
angle A equal to angle B. So I said that if you have an isosceles, if you have an isosceles triangle, if you have an isosceles or equilateral triangle, I told you that if you draw an altitude, if you draw an altitude in an isosceles triangle, it will always bisect the base. So you use RHS theorem, and by using RHS theorem, what you get the fact, what you get that here BD is equal to DC. You will get the fact that BD equal to DC. You get the fact that the altitude in the case of isosceles triangle or in the case of equilateral triangle become the median. You remember what is median? Median is the line from vertex to on the opposite side which always bisect the base. So here you get the corollary from here, although we know that very well. I'm just giving an instance. So here the corollary, what you get here, that the altitude from the vertical angle on the base in case of isosceles or equilateral triangle always bisect the base. So that is the output what we get. So the output, what this machine, suppose this machine, the inputs are basically your decision variables, what you're putting it there. So inputs are being put with a support system called axiom. So when you put those out inputs in the theorem, so then you manufacture the theorem, and then the finished good what you get, those are called as corollary, which you get as the output. So that we call as corollary. So here we studied about terms like statement, we studied about axioms, we studied about postulate, we studied about theorems, we studied about corollary. Clear, Dhwani?
yes, sir.
So then like talking about Euclid axioms. So Euclid said certain axiom, this theory and all we can read that. So when we talk about Euclid axioms, so you can read this the Euclid axioms. So here, yeah. So these are the axioms which are in postulate by Euclid. So you can see these axioms which will be postulated by Euclid. So these are Euclid axioms. So these are 7 axioms which are postulated by Euclid. So we call this. So this I'll call it as Euclid. These are basically Euclid axioms. So Euclid remarkable work. So things which are equal to the same thing are equal to one another. Just like suppose if A is equal to B and C equal to D, or if you say A equal to B or B equal to C, then it means A equal to C. This is what the first statement in axiom of Euclid. So things which are equal to same thing. So A is equal to B and C is equal to B. So automatically it means A equal to C. So that was the first axiom which was proposed by Euclid. Okay, self-explanatory. Next thing, if equals are added to equal, if equal are added to the equal, then the whole are equal. So like if I say A equal to B, if I say C equal to D, then if you add them, then A plus C will be equal to B plus D. So if equals are added to equal, then wholes are equal. I hope you understood this, Dani. So this is second thing. Third thing, if equals are subtracted from the if equal are subtracted from the equal means A minus C will be equal to B minus D. If equals are subtracted from the equal, then the remainder are equal. Okay. Fourth axiom, things which coincide with one another are equal to one another. Things which coincide with one another. So coincide with another, you remember this we use in many scenario like congruent
Yes.
triangle ABC, and then we say triangle DEF. So we say triangle ABC is congruent to the triangle DEF, like a mirror image or something like that. So they are same. So you can put them, you can superimpose them together. So there's a one line in linear equation. If you remember, I have taught you. When you talk about line, line can have unique solution. They can have infinite solution. They can have no solution. If you remember, in term of line, when I said if A1 by A2 is equal to B1 by B2 equal to C1 by C2, it means such kind of line will have infinite solutions. In linear equation, we studied three kind of solutions are possible. If two lines are there, A1x plus B2y is equal to C1 and A2x plus B2y is equal to C2. If two lines are there, you remember linear equation, it always give you lines. So you have two lines, so the two lines can be parallel, or the two lines can have unique solution, means they will intersect at one point, or the two line can be one same thing only. Same means like 2x plus 3y is equal to 7 and 4x plus 6y is equal to 14. If you notice, if you solve these two lines, now if I ask you, can you solve this equation and tell me the solution of x and y? So the solution of this equation will be infinite solution, because they are not two different lines. They are same line only. They are superimposing each other. So they are same thing only. So this is the third axioms, that if sorry, fourth axiom, that things which coincide each other, two things, if you can superimpose or coincide each other, so then they are not two different things, they're same thing only. Okay, so then fifth thing, the whole is always greater than parts. Very simple. So whole one is always greater than half. Anything, any fraction in the form of p by q, where if your q is greater than p, is always less than one. I hope you understand it.
Yes, sir.
So the whole is always greater than the parts. Then the sixth axiom is things which are double of same thing are equal of one another. So things which are double of same thing are always equal to one another. Like A is equal to 2B. Okay, which are double of same thing. And C is equal to 2B. Automatically it means A equal to C. So this is the sixth axiom. Okay, then the same thing in the seventh. So if A is equal to B by 2 and C is equal to B by 2, so automatically means A is equal to C. That was the sixth, seventh axiom. So you can use in half, you can use in double, you can ask in triple, you can use anywhere. So all means same thing. Just once you read it, let me know if you have any doubt.
Yes.
So these are the axioms which are proposed by Euclid. Then we can continue further. Na, Dhoni?
Yes, sir.
So then Euclid postulates. So all the theory things are there. This being explained. So these are the five postulates of Euclid, that a straight line may be drawn from any one point to any other point. So what do you mean by this? What do you mean by first postulate, Dhoni? That means that there's only one and only one line which can go through the two lines, 2 points. So from 2 points, you cannot have more than one line. So you cannot have more than one line which can pass through 2 points. So this assume that there's only one unique line which can join the two distinct points. From one point from one point you can draw infinite lines. So from the one point
Yes, sir.
you can draw infinite lines. So infinite lines can be drawn. So infinite lines can be drawn from this point. Okay, but connecting 2 points, if you have 2 points, they cannot be more than one line. They cannot be more than one line which can pass these 2 points. So these two distinct points, when I talk about, they can be only one line. If I talk about the concept of little bit of permutation combination, you just simply remember this. Simply, you remember that if you have n points, no, if you have n points in a plane, if you have n points in a plane, if somebody asks you, there n points are there in a plane, and if somebody asks you that how many straight lines are possible, how many straight lines are possible, if anybody will ask you number of straight line possible, then your answer will be NC2. Remember, I know right now you don't know what is NC2, sir. You have not taught me combination and all. It will come in future. All you remember this, simply you by heard this, like the way you by heard axioms, no? So we never question axiom. Like the same way you by heard this, it will come very soon in very soon. The number of straight line possible, if we have n points in a plane, number of straight line possible will be n into n minus 1 by 2. Something like n persons are attending a party. How many handshakes can happen? NC2 handshakes. So like that, you just remember this. Somewhere in the future, we'll do PNC, and definitely these things will come to us. So you connect 2 point, you will get a line. Why you write, sir, NC2? If you understand there n points are there. So by connecting 2 point, we'll get a line. So just now the first postulate of the Euclid, which says that a straight line may be drawn from one point to any other point. So it means that there's a unique line which can join the two distinct points. So using that concept, you join 2 points, you get a line. You join 2 points, you get a line. So how many lines are possible? So you will have NC2 line possible. I hope you'll remember this. If I say that out of n points, if I say out of n points in a plane, out of n points in a plane, if m point, this question comes, one of the favorite questions, this is what I'm writing for UPSC, NTSC, any exam, CDS, any exam, out of n points in a plane, if m points are collinear, if m points are collinear, okay, out of n points in a plane, if m points are collinear, the number of straight line possible, number of straight line possible, so that will be NC2 minus MC2 plus 1. So you remember this. Collinear means the same line, like they are in like 180 degree. The angle between the 2 point is one. If you draw a line on that, The angle is 180 degrees. So if you have n points, they should be non-collinear points. If the collinear point, then they'll just end up in drawing one line. So I'll explain these things in future when I'll teach you PNC and all. You just need to remember this. For the time being, you just remember this. Something like axiom, you can buy her this. So number of diagonal. You understand, no? What is diagonal?
Yes.
Number of diagonal of an n-sided polygon. So you have a polygon having n sides. What is the number of diagonal in that? NC2 minus n. So these are all based on the same concept. So which we'll study like you want to go to abroad. So GRE, SAT exams. What if you write in future? One of the favorite question of that. So 3n square minus 3n by 2, no? N into n minus 1 by 2 divided by n. So n square minus n, yeah, n square minus 3n by 2, correct. So one of the favorite question of GRE exam. GRE, lot of question comes in geometry. GRE, SAT, or abroad, ACT, lot of exam happens depending from country to country. One of the favorite question that comes. So the first postulate, we studied about axioms. No, we studied about axiom. I told you what is axiom. I told you what is postulate. So such forms of axioms
Yes, sir.
used in geometry, they are postulates. Axioms are self-evident true fact which we use any discipline of maths. So we talked about 7 axioms. Now we are talking postulates. So we will now only concentrate on geometry part. So the first postulate was a straight line may be drawn from any other point to any other point. Note that this is postulate which tell us that at least one line passes through two distinct points, but it does not say that there cannot be more than one such line. Okay. However, in his work, Euclid has frequently assumed without mentioning that there's a unique line joining the two distinct points. That is what I said to you. So then the second postulate was given the two distinct points, there's a unique line that passes through it. That is what we already said. Axiom. So then postulate 2, a terminated line can be produced infinitely. So this, what do you mean by the second postulate, Dhoni? You know what is line, what is line segment, what is ray, Dhoni? What is the difference?
Yes, sir.
Line segment and ray.
So a line is a endless.
Correct. So line
A line is endless. Line segments has endpoints.
define magnitude. Define magnitude. Correct, na Dhoni? In
Yes, sir.
and ray is fixed at one point.
One point, but the other point is endless.
Yeah, very good, Tony. So this second postulate of Euclid is saying that a line segment, terminated line means a line segment. So terminated line means a line segment. So a line segment or a terminated line, if you allow it to move, if you do not restrict it, if you allow it to move, then it will move indifferently in their direction. So this is what diagram which you can easily understand. So we can, so a line segment can be extended to either side to form a line. So you can understand this. The third postulate of Euclid says that a circle can be drawn with any center of any radius. So the third postulate of Euclid says that you give me a center. Euclid is saying that you give me a center, you give me a center, you give me some radius, some value of radius. Doesn't matter. You tell me the radius. How much is the radius? Okay, and then what I can do, I can draw a circle. So this is basically is what the third postulate of Euclid. I hope, how will you define a circle? You can define a circle basically. Circle is basically it is an amalgamation of different points. It is an amalgamation of different points forming a curve, and that curve is equidistant from a fixed point. So a curve where the distance of any point on that curve, if that is equidistant from a defined point That way we can define a circle. So the third postulate of Euclid says that a circle can be drawn with any center with any radius. So that is the third postulate of Euclid. I hope you understood this. Okay.
Yes,
We
sir.
the fourth, so the fourth postulate is again very simple. The fourth postulate of Euclid is all right angles are equal to each other. I don't think we need any explanation for this. So when you talk about right
Yes, sir.
angles, so all right angles are
90
90 degrees.
degrees, sir.
So definitely they are equal to each other.
Yes.
So the last and the very important for your exam perspective, the fifth postulate, 100% like you will get the theory question. I hope by this time you would have got an idea that in exam you will get theory question about
Yes, sir.
Euclid postulates. You have to buy her this. Although this looks very easy and all, it look like I know all this thing what you're talking about. But even then, this will come in exam. And out of all the five postulate, the most important postulate is the fifth postulate. Before I talk about this fifth postulate, before that, I just want to explain you a few things. So this fifth postulate is actually laid the foundation. The fifth postulate is actually laid the foundation of the concept of parallel line. So the concept of parallel line can be understand very easily from the fifth postulate. So what fifth postulate is saying that, let me explain you that part. So if you take two lines, okay, if you take two lines, something like this, which so something they are not straight, okay, something they're curved, something so inclined with some base. So if you draw, if you have two line like this, okay, suppose these two lines are C and D. Suppose this is one line having end CD and this another line having the end, suppose this is EF. Okay, then if you draw a transversal, you know what is transversal already. The concept of parallel line I discussed. Now we are going back, reversing. We knew about parallel line. From parallel line we learned the concept of corresponding angle, alternate interior, opposite angle, the sum of two angles, adjacent angle, sum is supplementary, all that we studied. Now we are reversing it back. Now forget parallel line, forget that you don't know, you never heard of parallel line. Now think think now that there is a two line, maybe they are inclined with certain angle, and you draw a transversal line. Transversal line is the line uh, which transversal will not be correct here, because transversal bisect a parallel line. Two parallel lines, if it bisected by third line, then that line is called transversal line. So here AB is, I cannot use the term transversal line for AB. So just assume that there's a line called AB which bisect two lines which are not parallel to each other. Assume that you know about parallel lines. It's like you know about God, but you're not trying to prove God exists or not, but you're just assuming the certain scenario. So here also we are assuming that maybe you have heard of something theorem about parallel line, but you are not yet to prove parallel line. So there, suppose there are two lines CD and EF which are not parallel to each other, and there's a line AB which bisect, which not bisect, it will just cut the two lines. Okay, then what it's saying that, then it is saying that this line AB, when it will cut CD and EF and goes in infinitely in a direction, then definitely it will create an angle. Definitely would have created an angle. Suppose this is angle X, suppose this is angle Y, okay, and suppose this is angle M, and this is angle N. Okay, fine. So then what, sir? So what the fifth postulate of Euclid says that, the fifth postulate of the Euclid says that when AB has cut CD and EF, forming some interior angle, then if you take one set of adjacent interior angle, if you take one set of adjacent interior angle, the sum of the one set of adjacent interior angle, it is X plus Y. The another another set, the sum of interior angle of another set, if suppose M plus N, this was X plus Y. Now in if you compare these two scenarios, there would be one scenario where the sum would be less than the two right angle. Means two right angle matlab 180 degree supplementary. In other scenario, another set, they may be the sum of two adjacent angle maybe the sum would be more than two right angle. Here in the postulate of Euclid, instead of 180-degree, instead of term supplementary, the term which is being used is two right angle. So I'm again using the term two right angle. So please don't get confused. So there would be a scenario. Are you understanding, Dhoni?
Yes, sir.
So there would be two scenarios. It can be this x plus y, the sum, if you take x plus y sum, it can be more than 180-degree, it can be less than 1.
Less than 180 degrees.
So the m plus n, it can be more than 180-degree, it can be 180 less than 180-degree. So what Euclid in his fifth postulate is saying that, so whichever pair of adjacent angles are having a sum which is less than two right angle, whichever pair is having a sum which is less than two right angle. Okay, so if you consider that end, this is a line, no, CD and EF is a line which is extend infinitely in the two direction. Now if you take that end, that end where the sum is getting less than 180-degree, and if you extend that end infinitely in the direction, there would be a scenario where these two lines will bisect, or these two lines will intersect. So this is what the Euclid has said in his fifth postulate. So now we'll talk about that. If a straight line, okay, if a straight line that was AB, okay, if falling on two straight lines like CD and EF, making an interior angle on the side, on the same side of it, if it taken together, and it is less than the two right angle. Okay, I said no, x plus y less than 180-degree. Two right angle means 180-degree. Then the two straight lines that CD and EF, if produce infinitely where meet on that side where the sum is less than 180-degree, on that side on which the sum of the angle is less than two right angle, then they'll meet somewhere. I hope you understood this. So this is the
Yes, sir.
postulate, and you have to buy heart this, because in exam, if it come, the question will come from this. This another name of
Okay, sir.
the another name of this is play fair axiom. Another name of this fifth postulate, the most important, is play fair axiom. So this from this you can, this will definitely, the question will come in your exam, and this fifth postulate was later on modified to give the, what you say, the property of the this parallel line, the concept of parallel line. This is what I said. So you can see that. So now here, so you, this verb and all, I don't forget what is verb and verb adjective and all. I don't remember. You can read it, you like it more. So here when we say this axiom, and this actually the fifth postulate is actually laid the foundation to understand the concept of parallel line. Like for the parallel line, what is being mentioned, that like suppose if there's a line L, okay, and in for that line L, if there's a point P which does not lie on the L, suppose there's a line L, what is being mentioned here, that suppose there's a line L, suppose there's a line L and there's a point P, there's a line L, there's a point P which does not lie on that line L, there's a point P which does not lie on the line L. Okay, then there exists a unique line, then there exists a unique line. Okay, now through this point, you know that there's a point P which does not lie on line L. Then you know that from point P, I can draw infinite lines. Correct, Nadoni? From the point P, if I have to construct lines, I can draw infinite lines. I can draw infinite lines here. I can draw infinite lines there. But there would be one line. There would be one line which will pass through P. There would be one line which will pass through P, and that will be parallel to L. That is actually the derivation from the fifth postulate. So if I write that, for every line L, suppose L talks about generic purpose. Okay, and for every point P and for every point P and for every point P, again point P is a generic point, and for every point P, 1 minute, for every line L, L doesn't mean any defined definite line. It's generic any line L, and P is any point which does not lie on that line. For every point P, for every point P not lying on L, not lying on L, for every point P which is not lying on L, so there exists there exists a unique line, there exists a unique line, there exists a unique line which passes through P, which passes through P, which passes through P, which passes through P, which passes through P. Okay, and it is parallel to it, and it is parallel to it. So you know the concept of parallel line. So concept of parallel line says that the two lines which never meet, no, the two lines which will never meet, such lines are called parallel line. So if you you do this in linear equation, already I did for you kind of revision. So if a1x plus b1y equal to c1 and a2x plus b2y is equal to c2, when they are parallel line, if when they are parallel line, if a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. So if this happens, they will give you no solution. They'll give you no solution. They are actually parallel lines. They're actually parallel lines. Are you getting this, Dhwani?
Yes, sir.
And this, Dhwani, I just teach you a little bit something which is not there for the ninth curriculum. The same thing, concept of parallel line, when we study coordinate geometry, Dhwani, then we'll say the slope, if the two lines are parallel, then the slope of one will be equal to the slope of two.
Slope of the other. Yes, sir.
Yeah, so you know that very good. Yeah, if you know, I'm very happy. So we normally represent with the symbol M1, M2. If the slopes are equal, means they are parallel. If the product of the slope is equal to -1, then they are perpendicular line. The very common.
Okay, sir.
In 10th standard, next class you'll study coordinate geometry. This is the property of perpendicular line. This is the property of parallel line. We should always remember. So this is, we should
Okay.
always remember this one. Okay, so this you always remember this. So now you understood this. Now this going further, if I say you can always remember that the two distant intersecting line cannot be parallel to the same line. This you already know. If the two lines get intersected or if they are giving unique solution, they cannot be parallel. So three things always remember in line, that they can have infinite solution, they can have a definite solution, or they will have or no solution. So in unique solution, when a1 by a2 is not equal to b1 by b2 is not equal to c1 by c2, it means the two lines cut, they will meet somewhere. You remember, if the two line meet, if you solve x and y, two linear equation, if when you are solving, you are getting the value of x and y, linear equation chapter, this thing will keep on coming. Remember, if the two lines are cutting each other, they will not cut more than 1 point. It means they will give you unique solution. So this they are, because they, if they are giving unique solution, they cannot be parallel line, or they can give you no solution. No solution, then a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. No solution. Or infinite solution, when they equal, a1 by a2 equal to b1 by b2 equal to c1 by c2. So you like two distant line, they cannot have more than 1 point in common. So you need to always remember that the two distant line, two distant two distant line two distant line cannot have cannot have more than cannot have more than 1 point in common. 1 point in common. So how to prove this? So two distinct line cannot have more than one point in common. If see, Dhwani, three kinds of lines are there. Again, three kind of solutions possible. Either they
Yes, sir.
infinite solution, unique solution, or no solution.
Yes,
Infinite
sir.
solution means two lines are superimposing each other. Means they are not two distinct lines. I hope you understand.
Yes, sir.
Line means they cannot superimpose each other. So here, if I'm talking about distinct line, here, if I'm talking about distinct line, here, if I'm using the term, here, if I'm using the term called distinct line, then they will be parallel line or they will be non-parallel. If I'm using the term called distinct line, then then you understand, no, distinct line and superimposing line cannot exist together. They're mutually exclusive event. So they can be either parallel line, they can be either parallel line, or they can be either non-parallel line. They can be either non-parallel line. If they are parallel line, then number of intersection will be zero now, because two lines are parallel because they never meet. है ना? We say no for love stories,
Yes, sir.
parallel love story, they will never meet. He, Ranja, or Romeo, Juliet, whatever. So the parallel line, the number of intersection is zero. Non-parallel line, the number of intersection will be one. Non-parallel line, the number of intersection is one. So they will meet only at one point.
1 point. Yes, sir.
More than one point. So here, thereby we can prove the statement that the two distinct line cannot have more than one point in common. This part, have you understood this, Dhwani?
Yes, sir.
Okay, so now can you just revise, Dhwani, whatever I said in the Euclid geometry from beginning? A quick revision from your end, what you understood.
Yes, sir. So you told in Euclid geometry there's something called statement, axiom, postulate, theorem, and corollary. And a statement is the thing which can be judged by true or false. We can say if it's true or false. Axiom is self-evident, true statement. Then postulates is a self-evident true statement, which is only used in geometry. And axiom is a self-evident true statement, which is not only for geometry. Theorem is a statement that needs proof. And corollary is a statement whose truth can be easily detected from the theorem.
Correct. Then do you remember Euclid axioms? 7 axioms are there, all
Yes, sir.
common, but remembering them is a difficult thing. Can you recall
So,
it?
so one is uh, when if the equals are subtracted from the equals, the remainders are equal.
Similarly added. Does
Yes, sir. Same thing for added.
correct.
Then the whole is greater than the part.
Correct.
And the things which are half of the same things are equal to one another.
Correct. Correct.
And the things which are double of the same thing are also equal to one another.
Correct. Correct. Then if A equal to B and C equal to B, means A.
If we are say
equal
the
to C.
things which are same thing are also equal to one another.
Then one thing is left, that coincide. If two
the things which coincide with
equal.
one another are also equal.
Correct. Very good, Dhwani. Then Euclid 5 postulates.
Yes, sir. So one is the first one is a straight line can be drawn from any one point to any other point.
Means
Then
what you said is 100% correct. The other way to understand that from two distinct points, only one line can be drawn.
Yes, sir.
Then one line which can pass two distinct points.
Yes, sir. And another one is a circle can be drawn with any center and any radius.
Very good, very good.
All right angles are equal to one another.
Very good.
Terminated line can be
Produce
infinitely. Yes,
and the
sir.
fifth one is very big, so there's no point. I hope you remember that, the diagram, that thing. Fifth one, yeah. This
Oh,
you
yes, sir. So if a straight line falling on two straight lines, yes, sir.
So the angle what form if the sum of two adjacent angle if
Yeah, if the same side is taken less than two right angles,
Mhm.
yeah,
Then if
then
that side if you extend
yeah, and the
infinitely
two
they'll
straight
meet.
lines are produced infinitely,
Hmm.
and
Then they will definitely will meet. They'll meet.
yes, sir, they meet on the sum of the angles, which is less than right angles.
Yeah. So this is all we have done. Okay,
Yes, sir.
we'll continue this Euclid geometry tomorrow. So at
Okay, sir.
5 o'clock we'll do the area and volume chapter.
So can we do it at 4?
4:30 actually 4:30 if you want, and you have any
Uh,
at 5 o'clock.
no, sir. Yes, I have to help my
No
mom, sir.
problem. Tell. No problem. You tell. You,
Yeah, I had to help my mom. So
so, guys, I hope you have understood the concept of Euclid geometry, what we have done so far in this class. We'll continue in another class and we'll discuss the more logics, the more theorems, the more axioms, the more postulates which were being discussed, which is being given in NCERT Euclid geometry chapter. So, I have understood what all I have done so far till now for this class. So with that intention, I like to wind up the class. Thank you, everyone. I'll see you all. Bye.